Okay, let's talk about acceleration. So, the definition of acceleration is a change in velocity. All right, so causing an object to either speed up, slow down, or change direction, actually, as well. Okay, so change in velocity. The units for acceleration are meters per second squared. Sometimes you also see meters per second. And that's why you have 2 per second, so 2 seconds in the denominator, which is why you get that second squared. Okay, and basically what this means is that you're changing the velocity a certain meter per second every second. Okay, so if you have an acceleration of 5 meters per second squared, that means that the velocity is going to change by 5 meters per second every second. That's what that unit means. Now, just like velocity and displacement, acceleration is a vector quantity, which means that it has both a magnitude and a direction. The average acceleration equation, which is one of the only acceleration equations that we use, most of the problems that we will be doing, well, all of the problems really with acceleration that we will be doing, are just problems that have average acceleration, so the same acceleration over a period of time. So the average acceleration equation is acceleration is equal to the change in velocity divided by the time interval. So we have our final velocity minus initial velocity divided by the time. So sign of acceleration is usually something that people mess up a lot because in common English speak that we use in our everyday lives, a lot of people use this term deceleration and negative acceleration interchangeably. Like you think about something decelerating, it's slowing down, and people like to say that's a negative acceleration. Now, this is not always right, okay? So in physics, this is actually the wrong thing to say. Basically, the sign does not indicate whether an object is speeding up or slowing down in acceleration. The sign only indicates the direction of the acceleration vector, just like it indicates the direction of the velocity vector and like it indicates the direction of the displacement vector. So I like to give the example of a rollerblader. So someone on wheels. And we'll say that this rollerblader is going in the positive direction. So he has a positive velocity. All right. Now, if he has the wind at his back, meaning the wind is pushing him also in the positive direction, that wind is giving him a positive acceleration. Okay, so if he's going in the positive direction and he has a positive acceleration, what's going to happen? Well, he's going to speed up, right? That wind is pushing him in the same direction he's going. So if you have a positive velocity and a positive acceleration, you're going to speed up. Now, the trick here is that if he is then, instead of going in the positive direction, say he's going in the negative direction, his velocity is negative, but also the acceleration is in the same direction, the negative direction, so he still speeds up. So as long as the acceleration is in the same direction as velocity, he's going to speed up, whether that be both positive or both negative. Now, again, let's say he has let's say this direction is negative. Why not? Let's be rebels. Okay, so we're saying he's going to the right, and we're going to call the right the negative direction. Remember, I told you, as long as you keep your signs consistent, totally doesn't matter. You can say that the right is negative if you want to. So he's going to the right, which we're calling negative in this case. And then the wind, though, is in his face. So it's blowing him in the opposite direction. So now that force of the wind is giving him an acceleration to the left, which we're going to call positive. Since we called right negative, we have to call left positive. So velocity is negative here, acceleration is positive. When those two things are in opposite directions, he's going to slow down because he's going into the wind and that wind is pushing him back. All right, so the rule of thumb here is that if velocity and acceleration are in the same direction, so they're either both positive or both negative, the object speeds up. If velocity and acceleration are in opposite directions, the object slows down. So if velocity is positive and acceleration is negative, or if velocity is negative and acceleration is positive, the object will slow down. Here's a table that kind of summarizes this. Notice how the object is speeding up when the signs are the same for both acceleration and velocity, and the object is slowing down when the signs are different for acceleration and velocity.